Okay guys, for the first few videos, at least for this week, we're going to just be reviewing our confidence intervals. I'm going to go ahead and do these in the calculator since that's what I taught you on Monday. And then for anybody that was not there on Monday, I'm going to go through the steps on the calculator as well, so that way everybody knows what we're doing. So you have several homeworks on My Open Math for confidence intervals. So this one is specifically going over confidence intervals for proportions. It's the most recent one we did. So one thing that I want you to remember is p hat is equal to x over n. So as we read through this problem, to test a campaign, they sent letters to a random sample of 100,000. So that's our n, our total. And they received 4,781, so that's our n. So our p hat, we're just going to divide those. So I get a p hat of 0.04, I'll just call it 8. So give a 95% confidence interval for the true proportion of those from their entire mailing list who may donate. So on the calculator, if you remember, you go to Stat, we're going over to Test, and then make sure you're choosing the right one. Because this is proportions, we want a 1 prop z int. So don't get it confused with the 1 prop z test. So 4,781 donated out of 100,000, confidence level of 95. So here's our confidence interval. So it's anywhere from about 4.6 to 4.9%. Okay, so a staff member thinks that the true rate is 5%. Given the confidence interval, do you find that percentage to be plausible? So again, the confidence interval means we are 95% sure that the true population proportion falls somewhere between 4.6 and 4.9%. So, is it very likely that the true rate is 5%? No, because we're 95% sure that it's between 4.6 and 4.9. 5 is just a little bit outside of that. Okay, so moving on, a National Health Organization warns that 30% of middle school students have drank alcohol. A local health agency anonymously surveys 110 of the 1,212 middle school students, and only 21 of them report having drank alcohol. What proportion of the sample reported drinking alcohol? So that means we're looking for p hat. We're looking for our sample proportion. Now make sure that you're careful on a video, or I'm sorry, not on a video, on a problem like this. They give you these two values and you have to make sure that you're deciphering and using the right one. So they only actually surveyed 110. So the 1,212 is kind of just extraneous information. So 21 out of the 110. So we have a p hat of 0.19, so about 19%. Does this mean that the city's youth are not drinking as much as the national data would indicate? Not necessarily. So, just because we have one sample that is way less, does not necessarily indicate that our population, is a lot different. So, I'll let you write in kind of in your own words on that one. So creating our 95% confidence interval. So again, stat test. We're scrolling. Nope, sorry, I was on test. 1 prop z interval, 21 out of 110. So 11.7 to 26.4%. Is there any reason to believe that the national level of 30% is not true of the middle school students in this city? So here's kind of your main difference between question B and question D. Question D is very specific because it's asking for middle school students in this city. So I believe that based on our confidence interval, we can say there is reason to believe that the level of 30% is not true in this middle school in this city. So what I would say up here is, maybe we want to gather a bigger sample. We want to collect from more middle schools within that city to get kind of a clearer picture. Okay, so then the last one, to keep the margin of error at most 5%, how many middle school students do we need to survey? Now, it's really nice that the calculator will do these confidence intervals for us. However, problems like this is why we still have to know the formula and be able to do it by hand. So our confidence interval for proportions is p hat plus or minus z critical square root of p hat times 1 minus p hat divided by n. So everything beyond the plus or minus is the margin of error, and we want it to be 5%. Now, usually the most common mistake that I see here is people just start right out and they set it up 5 equals, but remember, for this 5%, we need to turn that to a decimal, so it's 0.05 equals z critical, so 1.96. Our p hat was 0.19 divided by n. So we need to solve this thing for n. So the first thing I'm going to do is divide both sides by 1.96. And one thing that I'm going to do, and I encourage you to try to do also, is try to do as much as you can in the calculator using that full decimal so that you're not rounding your answers, because if you round your answer now, it's just going to make your final answer off. And so that could create issues on my open math where they're asking for specific answers. So just for the sake of writing down my steps, I'm going to write down 0.0255 equals the square root of 0.19 times 1 minus 0.19 divided by n. So now, to get rid of my square root, I have to square both sides. So what I mean is just use the calculator, so how it says answer squared, don't try to retype that in. Keep it as exact as you can. And you're going to get some really nasty decimals, so this is another reason why you want to use the calculator as much as you can. 0.19, 1 minus 0.19. Okay, so then what I'm going to do is multiply each side by n to get this to cancel out, and then I have to divide both sides by this big nasty decimal. So what I'm going to do, I'm going to type in 0.19 times 0.81, because that's my 1 minus 0.19, divided by my answer. So what I'm doing is this 0.19, I went ahead and changed this to 0.81. Those are being multiplied. I have that in a big set of parentheses. And then to get n by itself, I'm going to have to divide by this nasty decimal, which I just used second negative to get it to put the previous answer in there. So in terms of sample sizes, we cannot have 0.5 people, so these we always want to round up. So 237 are needed to have a margin of error of 5%. Okay. Okay, in March of 2007, Gallup asked 1,006 adults whether they were baseball fans or not. 36% said that they were. Find the margin of error for the poll if we want to be 90% confident in our estimate of the percent of adults who are baseball fans. Okay, so one thing, p-hat was already given to us here, so that's really nice. Now, there's a couple of ways you could do this, so I'm going to show you how to do this by hand and using the calculator. So by hand, our margin of error formula, remember, is just your critical value square root of p-hat 1 minus p-hat divided by n. So this is relatively easy to compute. So first of all, our 90% confidence, and remember what that means is we're looking for these two critical values, one positive, one negative. We want 90% in the middle, so that leaves 10% left over, which has to get divided. So each one of these little tails is 5%. So when it asks for area to the left, we have to use 5%, not 10%. So we go to second vars, we're going to inverse norm. My area is 0.05. I keep my mean and standard deviation at 0 and 1 because I'm just using a standard normal distribution. So I get for this a z critical of 1.645. And you could find that on your chart as well. Okay, so I'm going to have plus or minus 1.645 times the square root of, remember p-hat has to be a decimal, and I had 1,006. So here's the way I would do this kind of step by step. 0.36 times 1 minus 0.36 divided by my sample size, take the square root of my answer, then multiply by my z critical. So I get a margin of error, so my give or take, we're looking about 2.5%. Now, if we wanted to do this using the calculator, what we would want to do is go ahead and run our one prop z interval just like normal. One thing you have to do here though is we need an x and an n, and we don't have that in this given information. We have n and we have p-hat. So if you remember, your formula for p-hat is x divided by n, so we just have to figure out what is 36% of 106. So I'm actually going to quit out of here, or I'm sorry, not 106, 1,006. And we can't have you know, a partial person. When we run this test in the calculator, it will not let us put in a decimal, so I'm going to round that up. So x is going to be approximately 363. So now I'll go to my one prop z interval and make sure you remember to change your confidence level. They wanted a 90% confidence level. So I come up with this interval of 0.3359 and 0.38574. So what we have to remember is right in the middle is where our p-hat is. So 0.36 is right in the middle. So in order to determine your margin of error, it's your wiggle room from that point estimate. So if I do 0.36 minus 0.33593, I get my margin of error. Likewise, I could do 0.38574 minus 0.36 and I get the same amount. So that's my wiggle room either way. Now this 0.025 we had over here, slightly different. I think we had 0.024 some decimal. And this is most likely because we had to approximate our x value. We didn't get an exact 36%. So either way, we end up pretty good. Oh, and you notice it's actually a little bit different, and that's because this 0.36 is not going to be exact. So let's see, 0.33 593 plus 0.38574. So this is what they have for their point estimate if we're using 363. Now 0.33593. So there's my margin of error, which gives me still the same 0.025 that we got before. Okay, if we wanted to be 95% confident, would the margin of error be larger or smaller? Find, I don't know why that says 55, that should say 99 to confirm. Okay, so this, when we did the activity the other day, we kind of talked about this. If this is our standard, we'll say 95. If we want to be more confident, so let's say 99% confident, you know, what's going to happen to this interval? So what we discovered is our interval is going to have to become bigger to make sure that we actually capture the real mean. So if we want to be more confident, it's got to be bigger. Now, keep in mind that your point estimate, no matter what size your confidence interval is still right in the middle. So your margin of error is the wiggle room from your point estimate to each end. So what you notice is when you increase your confidence, your entire interval gets bigger, and our distance from our point estimate to our ends gets bigger as well. So margin of error is now larger with more confidence. So then what I can do is quickly run that confidence interval and change that to 99%. So what you will notice is compared to my 90%, I now have 0.32. So I now go, instead of 34% to 39%, I'm going from 32% to about 40%. So that did indeed get bigger. Therefore, you know, the margin of error increased. So if I use their point estimate, let me jot this down because it's going to go away. And then 0.32183. So 0.3608 minus 0.32183. So there is my margin of error now. So we went from about 2.5% wiggle room to about 4% almost wiggle room. Okay, so now just some questions, basically true or false. For a given sample size, higher confidence means smaller margin of error. Well, we just talked about that. Higher confidence means larger margin of error. For a specified confidence level, larger samples provide smaller margins of error. This is true. If our confidence level does not change and we increase the sample size, that is going to make our margin of error smaller. We're going to get more accurate. So for a for a fixed margin of error, larger samples provide greater confidence. This is also true. Sample size always makes things better. When you can increase your sample size, it's always better. For a given confidence level, you can get a smaller margin of error by selecting a bigger sample. That's basically a rewording of B, so that one is also true. Okay, so a little more information on confidence intervals.